Okay, welcome back to the 5.7 notes. This is part 2 of the trapezoidal rule notes. And what I want to talk about is a formula that we can use so that we don't have to spend all our time writing that out. The trapezoidal rule, it actually is usually, to me, is kind of a little bit quicker than the others depending on the problem. So what I want to do is that let's say that we are approximating the area under the curve f of x from the interval from A to B with n trapezoids. Okay, so this is a general rule that will work for for any sort of situation. But what I want to do just real quick is just kind of draw a quick little graph of my function f of x. So here's f of x. Here's A, and here's B. And so what we end up having here is all these different trapezoids, okay? And the idea is that we want to add all these up, okay? So, but a general rule, and I just want to be able to write this out, that if I'm going to find the actual area under the curve between A and B of f of x dx, okay, using the trapezoidal rule, what I would do first is take my delta x, okay, and so then delta x, that's the first thing. Delta x is equal to b minus a over n, okay, and so, but that's going to be my first thing, okay. Calculate whatever delta x is, and then I'm going to divide that by 2, okay. And so then what I would then do is multiply that by the sum, and we kind of already discovered this, that I'm just going to take it times the first function value, f of a, okay, plus 2 times f, so this, I'm going to call this f sub 0 of a, f sub 1 of x, and then I'm going to go over here and call this plus 2 times f sub 2 of x, and then plus 2 times, say, f sub 3 of x. And I'm going to add up all those terms in between, so dot, 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 and then plus 2 times, say, f sub n minus 1 of x, okay, and that's my second to last term. And then my last term is just going to be f sub n of b, okay? So I'm kind of using a little bit of different notation here, and I want to explain what I'm doing. This is my initial y value. This is my first y value, okay? First y value. And I kind of denoted that as my, as my 0, and then I counted up, okay, this is my first, this is my second, this is my third, and so on, all the way until we get to the nth one. Okay, so this is my last y value. This is my last y value. Okay, and then all of the ones in between, okay, these are all the y values in between. Okay, and so, this is the idea of what we just did in the first example. It's just that I'm kind of using it so I can use it for any number of terms, any number of y values. But this whole thing is what I would want you to set up. Okay, you don't have to go through and set up each of the areas that I'd asked for. Just go ahead and you can just go ahead and write this. Okay, you can just put the delta x over 2 the first y value, and then 2 times all of the interior y values, and then plus your last y value, okay? So, but what I want to do is go ahead and look at example 1. And example 1 says that I want to approximate the area beneath the function f of x is equal to x squared plus 1 on the interval from 0 to 3 using the trapezoid rule with n equals 5 trapezoids. So let's go ahead and just draw a quick sketch of this. And so I want to approximate the area from 0 to 3. So I'm going to do 0, 1, 2, and then 3 of x squared plus 1. So that starts here at 1. And then if I plug in, I'm just going to think about my last y value. If I plug in 3 into this function, I get 9 plus 1, which is 10. So that's my last one. If I plug in 1, we get 2. All right, so I have 0, 1. I have 1, 2. And then I have, if I plug in 2, what do we get? 5. Okay. And then we get 3, 10. All right, so we have this graph here. And I know it says n equals 5 trapezoids. Let's do that with n equals 3. Okay, just make this a little bit easier for us. And so the first thing that I want to do, step 1 is calculate delta x. So step 1, my delta x is equal to 3 minus 0 over 3, which gives me 3 over 3. So delta x is equal to 1. Okay, that's my first step. The next thing that I want to do is get all my y values. So I'm going to use my red to do that. So here's the first y value, my second y value, my third y value, and my fourth y value. I'm going to go ahead and draw in my trapezoids here. And I know that this y value is 1. I know that at 1, I plug in 1, I get 2. If I plug in 2, I get 5. If I plug in 3, I get 10. Okay, so these are my different y values. And so, and I'm just going to go ahead and write those out here for step 2. F of 0 equals 1, f of 1 equals 2, f of 2 is equal to 5, and f of 3 is equal to 10. Okay, now step 3 is adding up all the area of all these trapezoids. Okay, so I'm going to do this. I'm going to say the integral from 0 to 3 of x squared plus 1 dx is approximately equal to, okay, I'm going to do this, delta x over 2 times my first y value, which is f of 0, plus 2 times f of 1, plus 2 times f of 2, and then my last one, I'm just going to put it out as a single, okay, and just put plus f of 3, okay. So I'm going to go ahead and substitute my numbers in for what I've got here. This becomes the integral from 0 to 3 of x squared plus 1 dx, and that's approximately equal to delta x was 1. Okay, so 1/2 times f of 0 is 1, plus 2 times 2, f of 1 was 2, plus 2 times 5, that was f of 2, is 5, and then plus 10, which is f of 3. Okay, and so as a result, all right, I'm going to get that the integral from 0 to 3 of x squared plus 1 dx is approximately equal to, let me do 1/2 times, okay, we got 1 plus 4 plus 10 plus 10. So that gives me 25, right? So the integral from 0 to 3 of x squared plus 1 dx is approximately equal to 1/2 times 25. Okay, and so that gives me 25 halves, okay, which is also equal to 14.5. Okay, so any of these work, doesn't really matter. So, but that's the idea, okay? So it's pretty simple once you get through it, but you just have to know what you're doing and be able to set this part up, okay? So remember delta x over 2, your first and last y values are by themselves, and then each interior other y value multiplied by 2 and add them together, okay? All right, let's take a look at example 2. The same type of thing. We're going to do, evaluate this over sine of x on the interval from 0 to pi. using the trapezoidal rule with n equals 4 trapezoids. So what I want to do is just kind of graph what this looks like real quick. Sine of 0 is at 0, and then let me do that this is pi. Let me do pi over 2, and then pi over 4, and 3 pi over 4, okay? And let me do this as 1. Let me do 1/2, and then let me do the square root of 2 over 2. Okay, so let's kind of do this. Let me do pi over 2 and 1, pi and 0, and then right here and right here. All right, so this does take a little bit of knowledge to know what this looks like, but you guys can do that. You already know what this looks like. So what I want to do is think about what these y values are on here, okay? And, well, before I do anything, let's do step 1, okay? Delta x is equal to pi minus 0 over 4, so delta x is equal to pi over 4. All right, and I'm going to go ahead and find all my different y values and start drawing my trapezoids, okay? All right, so step 2, I know that y of 0 is 0. I know that y of pi over 4 is equal to the square root of 2 over 2. I know that y of pi over 2 is equal to 1. I know that y of 3 pi over 4 is equal to the square root of 2 over 2. And then the last one, I know that y of pi is equal to 0. Okay, so let's go ahead real quick and just draw those trapezoids. Okay, and that's it. So I know this is 0, and that's 0. I know this is 1. I know each of these are the square root of 2 over 2 and the square root of 2 over 2. Okay, so now what I want to do is plug all of this stuff into my formula. So I know that the integral from 0 to pi of sine of x dx is equal to, or I'm sorry, is approximately, okay, I'm going to do delta x over 2 times y of 0 plus 2 times y of pi over 4 plus 2 times y of pi over 2, and then plus 2 times y of 3 pi over 4, and then plus just a single y of pi. Okay, and I'm going to substitute my values in. We'll just evaluate. So my integral between 0 and pi of sine of x dx is approximately, and I'm going to plug pi over 4 in for delta x. So I've got pi over 4 divided by 2, okay? And I've got 0 plus 2 times the square root of 2 over 2 plus 2 times 1, and then plus 2 times the square root of 2 over 2, then plus 0 again. So this one isn't terrible, but let's go ahead and write it. 0 to pi of sine of x dx, and that's approximately, if I've got pi over 4 divided by 2, that's the same thing as taking 1/2 times pi over 4. Okay, and then I get the 2's divide out here, so I just get the square root of 2 plus 2 plus the square root of 2. Okay, so then I get the integral from 0 to pi of sine of x dx, and that's approximately pi over 8. Okay, 1/2 times pi over 4 is pi over 8. And then I multiply that by the sum of all these numbers, and so I got the square root of 2 times, so that's 2 times the square root of 2 and then plus 2. And this ends up giving me a value of approximately 1.896. Okay, and that's that. Okay, so, again, not too terrible, all right, but just follow what we know, all right? So now we've got this next one, okay, and so it wants me to do, in example 3, find the area between x equals 1 and 8 using the trapezoidal rule with n equals 4 trapezoids. And let's go ahead and change that to n equals 7 trapezoids to make this a little bit easier on ourselves. Okay, so the first thing I want to do is calculate delta x. So number 1, calculate delta x. And that's going to give me 8 minus 1 over 7. So then delta x is equal to 7 over 7, which is just 1. So delta x is equal to 1. Okay, now what I want to do is find all my y values. Okay, so I'm going to find part 2 in f of 1, that's 10. And I'm just looking off the graph here. F of 2 is equal to 15. Okay, f of 3 is equal to 20. F of 4 is equal to 15. F of 5 is equal to 20. Okay, f of 6 is, what is that, 30? F of 6 is equal to 30. F of 7 is 35. And then f of 8 is 25. Okay, all right, and those are all right. Okay, so now what I want to do, I know what my delta x is. I know what all these y values are. You can go in and draw the pictures of those trapezoids if you want, or if you just remember what you're supposed to do, it's really not too bad. So what I want to do is I'm going to integrate between 1 and 8, okay, of f of x dx. And that's going to be approximately, I'm going to do delta x over 2 times f of 1 plus 2 times f of 2 plus 2 times f of 3 plus 2 times f of 4 plus 2 times f of 5 plus 2 times f of 6, 2 times f of 7, and then just a single plus f of 8, okay? So my last term and my last y value and my first y value are singles. Every other y value in here is being multiplied by 2, okay, from our formula. So I'm going to come in here and just write down what we've got, okay? So I've got the integral from 1 to 8 of f of x dx, and that's approximately, delta x is 1, so 1/2 times f of 1, which is just, okay, so I got 10 plus 2 times 15 plus 2 times 20 plus 2 times 15 plus, okay, 20, 30, 35, 25. So 20, 30, 35. So plus 2 times 20 plus 2 times 30 plus 2 times 35, and then plus 2 times, just 25 after that. Okay. All right, let me just verify that I've got this. All right, I should have 8 terms here. All right, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we're good on that front. Now let's go ahead and evaluate this a little bit and see what we get. So the integral from 1 to 8 of f of x dx is approximately, okay, 1/2, and I've got 10 plus 30 plus 40 plus 30 plus 40 plus 60 plus 70 plus 25. Okay, and I'm going to go ahead and plug all this into my calculator, but first let me do the integral from 1 to 8 of f of x dx is approximately equal to, and I'm going to go ahead and plug this into my calculator real quick. That's what we get. And after calculating that on the calculator, this is going to give me a total area of 152 0.5 units squared, okay? So that's what I've got, all right? And so, you know, as long as you know how to set it up and write the equation, that's the important thing, okay? So you can kind of start, you don't have to always draw the picture and do it from the picture. If you're comfortable doing it this way and just writing it out, then I suggest doing that. So I hope you enjoyed this video, and that's all I got for 5-7. Please get started on the homework. Thanks, bye.